All right, so here we go on our lesson on the least common multiple. After this lesson, I should be able to find the least common multiple of two or more whole numbers that are less than or equal to 12. So first we need to check out our vocabulary terms. So a multiple is a product of a number and any whole number. So when I'm listing the multiples of a number, it's literally if I multiply the number, what are those answers that I get? And those are called multiples. But the key term here is that they have to be whole numbers. If they're not whole numbers, they are not multiples. All right, so let's take 2 for example. So my multiples of 2 are 2, 4, 6, 8, 10, 12, 14, 16, and so on. All right, so they're technically your count by numbers. So if I were to say 5, if I count by 5s, it's 5, 10, 15, 20, 25, 30, so on and so forth. All right, so if I'm trying to find the least common multiple is the smallest number that 2 or more given numbers can multiply to. Okay, so before we looked for the greatest common factor, we were looking for the biggest, now we're looking for the smallest. So in this case, if I wrote down, let's do 12 and 10. Okay, sometimes what students like to do is they like to multiply and say the least common multiple is 120, but that's not the case. If I list my multiples here, it's 12, 24, 36, 48, 60. Well, I know that 60 is a multiple of 10, 10, 20, 30, 40, 50, 60. So my LCM in this case is actually 60. I know none of the other ones will work because they all have a different number than 0 that they end with. So my LCM here is 60. All right, so how are multiples and factors different? Well, the big difference here is that multiples are products of a given number, while your factors are quotients of a given number. Factors are how you get a product. Multiples are the products that you get. So for example, if I list the factors of 12, I know those factors of 12 are 1 and 12, 2 and 6, 3 and 4. Okay, again, my factors are always going to be less than or equal to the given number. Now I'm going to list the first 5 multiples. So the first 5 multiples of 12 are 12, 24, 36, 48, and 60. Notice all of these numbers, so my multiples are always greater than or equal to the given number. Okay? Multiples are what you get when you multiply. Factors are what you get when you divide the number. It's really important because that's the most common mistake that students make when they're looking for common denominators or common factors or common multiples. So let's take a look at the least common multiple and what's happening and what it means. So we have Clint who's training for a biathlon, and he will swim every 6th day, and he'll bicycle every 8th day. And we want to know on what days will he both swim and bicycle. So what's happening here, so we can take a look and say, okay, I'm going to highlight the days that he's going to swim. So every 6th day, so 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, and I'm sorry, that last one shouldn't be there. 1, 2, 3, 4, 5, 6. Okay, you'll start to notice that those 6th days that I'm marking, these are all multiples of 6. "66, 72, 78, 84, 90, 96, and that's as far as we're going. Now on every 8th day, he's going to cycle. So we'll go ahead and do red for cycling. So every 8th day. So 8, 1, 2, 3, 4, 5, 6, 7, 8. 8, 8, 8, 8, 8, 8, 8, 8, 8, 8, and that's as far as we get. Now notice we have pieces that overlap. Okay, so when we're doing this, we're actually finding what are called common multiples. And common multiples are products that two numbers have that are the same. And when we're counting off the days, those are actually, so on day 6, that's a multiple of 6. On day 8, that's a multiple of 8. So then on these days that overlap, those are going to be common multiples. Okay, so on what days will he both swim and bike? Well, 24 is a common multiple. 48 is a common multiple of 6 and 8. And then 72 is a common multiple of 6 and 8. And that says, oh, and 96 is a common multiple of 6 and 8. So that's what we're doing here when we're doing problems like this. Okay, and that's where the LCM can really help us, because if we want to know what's the first day that it'll happen, it's that smallest LCM. Right? But we're not always going to have a chart like this to go through and highlight and do all this work. So I'm going to give you a couple different methods for finding the LCM. So first, you can use the listing method. And what I tell students to do is to list the first 5 multiples of each number. So here we have 4, 8, 12, 16, 20. Here we have 8, 16, 24, 32, and 40. Here we have 12, 24, 48, oops, I'm sorry, 36 should go there, 36, 48, and 60. Okay, right now I have a common multiple for 8 and 4, but I don't have one for all 3 of them. So they can't have 4 in common because it's too small, and they can't have 8 in common because it's too small for 12. So none of these will work. Okay, 12 doesn't work because it doesn't work for 8. 16 doesn't work because it doesn't work for 12. Okay, 20 doesn't work because doesn't work for 8 or 12. Here we have 24 and we have 24. So if we list one more time and notice that we get 24 here, we can see that the LCM is equal to 24. Okay, so this is much like when we list the factors and we find that common factor. This is a little bit harder because there are so many multiples that you can choose from. So I always say start with 5 and then grow from there. All right, the next option that you have is to use the ladder method. Now we used the ladder method when it came to factors, and we were able to put all the numbers inside that ladder. When it comes to the ladder method, you can only do 2 at a time. So we're going to start with 12 and 42, and we're going to put them in our ladder. And we're going to find a common factor that they can both be divided by. Well, I know both of these can be divided by 2. 12 divided by 2 is 6. 42 divided by 2 is 21. I know both of these are divisible by 3. 6 divided by 3 is 2. 21 divided by 3 is 7. The common multiple here is 2. Now I actually have to pull these last 2 numbers out, okay, because I repeat those steps until I get down to 1. Now with the LCM, we multiply all the outside numbers. So I multiply the L. Alright, so now, and again, I cannot use the 1 because anything times 1 is the number itself, but I'm going to multiply all these numbers inside the L. So I have 2 times 3 is 6, times 2 times 7, 6 times 2 is 12, times 7, and 12 times 7 is 84. So right now my LCM is 84. However, I still have that 60 that I need to work with. So now I've done the 12 and I've done the 42, and I found the LCM was 84. So now I put 84 and 60 in a ladder together. I know that both of them are divisible by 2. And I get 42. There we go. 60 divided by 2 is 30. I know both of these are divisible by 3. 3 goes into 30 10 times. 3 goes into 42. Well, 3 goes into 4 once, and it goes into 12 6 times. Okay, and if we're not sure, we can always go off to the side. 3 goes into 4 once, minus 3. Bring down the 2, and that's 6. Minus 12 is 0. 16 and 10 have a common factor of 2. And I get 8 and 5. And then my common factor there is 1. And I have 8 and 5. And now again I multiply my L. And I get 2 times 3 times 2 times 8 times 5. Alright, well I know that this will give me 40, and actually I'm going to move this up here because I'm not going to have a lot of space. Now, you can see here that if I had listed these multiples, it would have been crazy long for me to do. So that's why I did the ladder method. So I have 2 times 3 times 2 times 8 times 5. So here I know this gives me 40 times 2 times 3 times 2. 40 times 2 is 80 times 3 times 2. The reason I did this first is because it's nice to multiply by a multiple of 10, because you can ignore that 0. So here I can do 8 times 3 is 24. Add that 0 on the end, times 2. 24 times 2 is 48, and add that 0 on the end. And the least common multiple of those three numbers is going to be 480. Now, can you imagine having gone through and listing all the multiples until 480 for these three numbers? This is why I give you the example of the ladder method, because a lot of times it goes a lot faster, especially when you have larger numbers, and students tend to do this more accurately because a lot of times we'll miss multiples by accident or we'll mismultiply. Alright, so how would we apply the LCM? To apply the LCM, we can look at this problem where we have a store who's holding a promotion. Every third customer receives a free keychain. Every fourth customer receives a free magnet. Which customer will be the first to receive both a keychain and a magnet? So my question here is, which one will receive a keychain and a magnet? And not only do I want to know who will, I want to know who will be the first one to receive both a keychain and a magnet. Okay, so it's every third customer and every fourth customer. So how this will work, you can use the listing method again. So the third customer will get a free keychain. The fourth customer will get a magnet. The sixth customer will get a keychain. The eighth customer will get a magnet. The ninth customer will get a keychain. The 12th customer will get a magnet. The 12th customer will get a keychain. Now notice we have 12 and 12. So this person, the 12th customer, will get both a keychain and a magnet. So the LCM here was the first common multiple that they had because it's the smallest one that they have in common. So anytime they're looking for the first person for it to work for, you know you're looking for the least common multiple. So the 12th customer will receive a free keychain and a free magnet. And we should actually put will be the first to receive a free keychain and a free magnet, because then every 12 customers after that should also get a free keychain and a free magnet. Alright, so you have this problem here that I would like you to try. It's written out in your notes for you. Alright, and I'd like you to use whichever method you feel most comfortable with, but I'm going to encourage you to use the ladder method. Alright, as always, if you have any questions, please be sure to write them down or email me so we can go over them in class.